Why do we study quadratics? At the IGCSE or O-level, you learned about straight-line graphs. These appear in the world around you, like a cell phone contract, where the monthly cost, y, is given by m multiplied by x plus c. Here, c is your fixed monthly charge and m is the cost per minute. Quadratic functions are different. They take the form y equals a times x squared plus b times x plus c, where a is not 0. These functions have unique properties like a line of symmetry and a specific maximum or minimum value. Studying quadratics is a bridge to more advanced mathematics. It helps us eventually understand complex functions like y equals 7x to the power of 5 minus 4x to the power of 4 plus x squared plus x plus 3. You've likely seen graphs like y equals 10 minus x squared. This curve represents a trajectory, the path of a ball through the air. In the 17th century, Galileo discovered that this shape, and even the vertical motion of a ball thrown straight up, can be modeled by a quadratic. Let us dive into the topic of solving quadratic equations by factorization. You are likely already familiar with two main ways to solve these equations algebraically: the factorization method and the quadratic formula method. In this section, we are going to consolidate what you know and build on that foundation to handle more advanced problems. We begin with the equation 20 minus 7x equals 6x squared. To solve this, our first goal is to reach standard quadratic form. We add 7x and subtract 20 from both sides, giving us 6x squared plus 7x minus 20 equals 0. Now we use the AC method. We multiply the leading coefficient 6 by the constant negative 20 to get negative 120. We need to find two numbers that multiply to that value but add up to our middle coefficient, 7. Those numbers are 15 and negative 8. Next, we rewrite the middle term. The equation becomes 6x squared plus 15x minus 8, x minus 20 equals 0. Now we factor by grouping. From the first pair, we factor out 3x, leaving 2x plus 5. From the second pair, we factor out negative 4, which also leaves 2x plus 5. This gives us our two brackets. 3x minus 4 times 2x plus 5 equals 0. Setting each bracket to 0 and solving for x, we find our final roots. X equals 4/3 and x equals negative 2.5. In problem 2, we start with x times the quantity 10x minus 13 equals 3. Our first step is to remove the parentheses by distributing the x, which gives us 10x squared minus 13x equals 3. To solve this quadratic, we need it in standard form, so we subtract 3 from both sides to get 10x squared minus 13x minus 3 equals 0. Now, using the AC method, we multiply the leading coefficient 10 by the constant negative 3 to get negative 30. We are looking for two numbers that multiply to negative 30 and add up to our middle coefficient, negative 13. Those numbers are negative 15 and positive 2. We rewrite our equation by splitting the middle term. 10x squared minus 15x plus 2x minus 3 equals 0. Next, we factor by grouping. From the first pair, we factor out 5x, leaving 2x minus 3. From the second pair, we factor out a positive 1, which also leaves 2x minus 3. This gives us our final factors. 5x plus 1 times 2x minus 3 equals 0. Setting each bracket to 0 and solving for x, we find our final roots. x equals negative 0.2 and x equals 1.5. In problem 3, we are dealing with a rational equation. X squared minus 2x minus 8 divided by x squared plus 7x plus 10 equals 0. The most important rule here is that a fraction can only equal 0 if its numerator is 0. So, we start by isolating the top part. X squared minus 2x minus 8 equals 0. To solve this quadratic, we look for two numbers that multiply to negative 8 and add up to negative 2. Those numbers are negative 4 and positive 2, which gives us the factors x minus 4 and x plus 2. Setting these to 0 gives us our potential roots, x equals 4 and x equals negative 2. But we aren't finished yet. We must check the denominator because division by 0 is mathematically impossible. We take the bottom, x squared plus 7x plus 10, and set it to not equal 0. This factors into x plus 5 times x plus 2, telling us that x cannot be negative 5 and x cannot be negative 2. Now, look at our results. Our potential root of negative 2 is actually on the forbidden list. Because it makes the denominator 0, we must reject it as an extraneous solution. That leaves us with only one true, valid answer, x equals 4. Problem 4 is a complex rational equation. 3 over x plus 2 plus 1 over x minus 1 equals 1 over the quantity x plus 1 times x plus 2. To solve this, our first goal is to clear the denominators. We identify the lowest common denominator as the product of all unique factors, x plus 2, x minus 1, and x plus 1. We multiply every single term by this LCD. Notice the cancellations. In the first term, x plus 2 cancels, leaving 3 times x minus 1 times x plus 1. In the second term, x minus 1 cancels, leaving 1 times x plus 2 times x plus 1. On the right side, the x plus 1 and x plus 2 cancel, leaving just x minus 1. Now we expand the brackets using FOIL. The first part becomes 3x squared minus 3. The second part becomes x squared plus 3x plus 2. On the other side of the equals sign, we still have x minus 1. Next, we combine our like terms on the left to get 4x squared plus 3x minus 1 equals x minus 1. To solve, we move everything to the left side, which simplifies the equation down to 4x squared plus 2x equals 0. Finally, we factor out the greatest common factor, 2x, giving us 2x times 2x plus 1. Setting each part to 0, we find our two final solutions, x equals 0 and x equals negative 0.5. In this particular problem, we are solving the equation. 6x squared plus x minus 2 divided by x squared plus 7x plus 4 equals 0. As we've learned, we only need to find when the numerator is 0. So, we focus on 6x squared plus x minus 2 equals 0. Since the leading coefficient is 6, we use the AC method. We multiply 6 by negative 2 to get negative 12. Now we need two numbers that multiply to negative 12 and add up to the middle coefficient, which is 1. Those numbers are positive 4 and negative 3. Now watch the middle term. We rewrite 1x as 4x minus 3x, giving us the four-term equation. 6x squared plus 4x minus 3x minus 2 equals 0. Next, we factor by grouping. From the first two terms, we pull out the greatest common factor, 2x, which leaves us with 3x plus 2. From the last two terms, we factor out a -1, which also leaves 3x plus 2. Our final factors are 2x minus 1 and 3x plus 2. Setting each bracket to 0, we solve for x. For the first bracket, x equals 0.5, and for the second, x equals -2/3. Both of these are our valid solutions. In this problem, we have a fraction with a high degree denominator. 2x squared plus 9x minus 5 divided by x to the 4th power plus 1 equals 0. Don't let that x to the 4th power intimidate you. The rule remains the same. For the whole fraction to be 0, only the numerator needs to be 0. So, we focus our energy on 2x squared plus 9x minus 5 equals 0. Using the AC method, we multiply the lead coefficient 2 by the constant -5 to get -10. We need factors of -10 that add up to our middle coefficient 9. Those numbers are +10 and -1. We rewrite the equation by splitting the middle term. 2x squared plus 10x minus 1x minus 5 equals 0. Now we factor by grouping. In the first pair, we factor out 2x, which leaves us with x plus 5. In the second pair, we factor out a -1, which also leaves x plus 5. This gives us our final factors, 2x minus 1 and x plus 5. Setting each bracket to 0, we solve for x. From the first bracket, we find x equals 0.5, and from the second, x equals -5. Since the denominator x to the 4th plus 1 is always at least 1, it can never be 0, so both our solutions are perfectly valid. In problem 10, we are solving for a side length in a right-angled triangle using the Pythagorean theorem. A squared plus b squared equals c squared. We plug in our given sides to get the equation. The quantity 2x squared plus the quantity 2x plus 1 squared equals 29 squared. First, let's expand these squares. 2x squared becomes 4x squared. For the next part, we use FOIL to expand 2x plus 1 squared, which gives us 4x squared plus 4x plus 1. On the right side, 29 squared equals 841. Now let's combine our like terms. Adding the 4x squareds together gives us 8x squared plus 4x plus 1 equals 841. To solve the quadratic, we subtract 841 from both sides, leaving us with 8x squared plus 4x minus 840 equals 0. To make the factoring easier, we notice all numbers are divisible by 4. Dividing the whole equation by 4 simplifies it to 2x squared plus x minus 210 equals 0. Using the AC method, we factor this into x minus 10 times 2x plus 21. Setting each bracket to 0 gives us x equals 10 and x equals -10.5. Since a triangle's side cannot have a negative length, we discard the negative root. Our final answer for x is 10. Now we look at the trapezium problem. Finding x. To find the value of x, we start with a formula for the area of a trapezium. Area equals 1/2 times the sum of the parallel sides times the height. First, we substitute our known values into the equation. We set 35.75 equal to 1/2. Then in brackets, we add the first side, x minus 1, to the second side, x plus 3, all multiplied by the height, x. Next, we simplify the terms inside the brackets. X plus x becomes 2x. and -1 plus 3 becomes +2. This gives us 35.75 equals 1/2 times the quantity 2x plus 2 times x. Now, we multiply the 1/2 through the bracket. Half of 2x is simply x, and half of 2 is 1. This leaves us with 35.75 equals the quantity x plus 1 times x. After distributing the x on the right side, we get x squared plus x. To solve the quadratic, we move everything to one side to set the equation to 0, giving us x squared plus x minus 35.75 equals 0. Using the quadratic formula, we find that the value under the square root simplifies to 144. The square root of 144 is 12. This leaves us with two possible values for x, 5.5 or -6.5. Since the height and length of a shape cannot be negative, we ignore the negative result. Therefore, the value of x is 5.5. We start with x squared minus 11x plus 29 raised to the power 6x squared plus x minus 2 equals 1. First, we apply the zero exponent rule. This rule states that any non-zero base raised to the power 0 equals 1. So we set the exponent equal to 0. 6x squared plus x minus 2 equals 0. Now we solve this quadratic equation. We split the middle term. 6x squared plus 4x minus 3x minus 2 equals 0. Now we group the terms. 6x squared plus 4x minus the quantity 3x plus 2 equals 0. Next, we factor each group. 2x multiplied by the quantity 3x plus 2 minus 1 multiplied by the quantity 3x plus 2 equals 0. Now we factor out the common binomial factor. The quantity 3x plus 2 multiplied by the quantity 2x minus 1 equals 0. Using the zero product property, we set each factor equal to 0. 3x plus 2 equals 0, or 2x minus 1 equals 0. So x equals -2 over 3, or x equals 1/2. Now we move to the second case. We use the identity property of 1, which states that 1 raised to any power equals 1. So we set the base equal to 1. X squared minus 11x plus 29 equals 1. We move 1 to the left side. X squared minus 11x plus 28 equals 0. Now we factor this quadratic. The quantity x minus 7 multiplied by the quantity x minus 4 equals 0. Again using the zero product property, x minus 7 equals 0, or x minus 4 equals 0. So x equals 7, or x equals 4. Finally, the solutions are -2 over 3, 1/2, 4, and 7. Boost your O and A level grades with Portelect Learning Channel. We provide affordable, expert solutions for mathematics, physics, chemistry, biology, and English to help you succeed. Subscribe, like, and share today to unlock the next update and master your exams.